board. I'm on. All right, so our topic is adding polynomials. And what I like to do is draw some common pictures around the common terms. So for example, for my x cubes, let's draw a heart. So I'm going to go around my x cubes, I'm going to draw a heart. Then I'm going to find another x cubed term, draw a heart. Now my x squareds, maybe I'll draw a square around it. And you really want to make sure, I guess it's a rectangle, you include the plus or the minus if there is a minus. And then the numbers or the constants, I'm going to put like a squiggly underneath. It obviously does not matter what shape you use or what design you use, but the point here is that you're identifying the like terms.
You just leave one blank.
What do you mean by blank? Yeah, you could, but the thing is, the reason I like to do something for each thing is to realize that I've covered them all. Yeah, because I'll oftentimes forget one. All right, so we're gonna add up our cubes, and don't overthink this. We're gonna basically combine the hearts. So I've got a 5x cubed and a 3x cubed. You can think of that as like having 5 hot dogs plus 3 hot dogs is 8 hot dogs, and your hot dogs are x cubed. So 5x cubed plus 3x cubed is an 8x cubed. Okay, now I'm going to combine my rectangles. So that's a 6x squared and a minus 12x squared. What is that?
Minus 6x.
Good. Minus 6x squared. And then the last thing I'm going to combine are my constants, which would be my 3 and my minus 10. So 3 minus 10 is negative 7. And you're done.
That's not that hard.
No, not at all.
Is it harder?
The thing, there's 2 mistakes people make. One is forgetting something in there. That's why I like to cover everything. You might want to cross things off if you want. The second mistake would obviously be messing up positives and negatives. All right, let's try another one. Why don't you guys try this one on your own? All right, what did your x cubed terms become?
2x.
Good. And I made these a little less interesting, but I just kind of bracketed them off. Okay, now I'm going to do my little upside down triangles. What's a negative 6x squared and a minus 12x squared?
Negative 18 squared.
And you know, on a quiz or a test, I'd give you a calculator. So if you're messing up on negatives, you might want to just throw a minus 6, minus 12 in your calculator. All right, and then what does a 3 plus 10 become? 13. I'm assuming we feel pretty good about this. So what do you think is after adding polynomials?
Subtracting.
Subtracting. And the thing we have to be careful about with subtracting polynomials is the minus and distributing it through. So let me show you what I mean by that. Go ahead and get this problem down, and we'll talk about that idea of distributing the negative. All right, so the negative here gets distributed to each of these terms. And so we have to rewrite the problem, and then it looks exactly like what it was before on the previous slide. So I drop this down, so this stays a 5x cubed plus 6x squared plus 3. But what does the next term become? A negative 3x cubed, and then a minus of a minus becomes what? Good, plus 12x squared, and again, minus 10 becomes plus 10. Now this problem looks exactly like the last slide, except I've written down something. You guys go ahead and put that together, and then I'll write the answer down so we can make sure we're on the same page. Two x cubed plus 18x squared plus 13. Yeah. The x cubes are 5 and a 12. Yeah. 5x cubed and a minus 3x cubed is a 2x cubed. And I've got my triangles, which would be a 6 and a 12, which gives me the 18. And then the 3 and the 10 are 13. All right. So this is our last problem today before I give you the homework. Go ahead and get this down. It looks like an SAT problem to me. It's scary looking. All right. First of all, have we ever seen this notation, this d of x and p of x, f of x? We've seen it?
Yes.
It's like a really fancy way of just saying y equals. So don't really obsess over that. So this is saying that my function, let's just call it d, is going to be equal to the p minus the r. So d of x is going to be equal to my p of x, which is this, So 2x squared minus 3x plus 1 minus my r of x. What do I have to remember to put after I've done that? Parentheses. Because I'm subtracting the whole thing, not just the first term. So I'm going to put parentheses, and then I'm going to rewrite the r of x. Next step is going to be to distribute. Okay, and after I've distributed, I'm just going to identify my x squared terms, my x cubed, my x's, and then my numbers. So you guys should help. I mean, just check my work here. It's just a plain old x cubed, and then a 2x squared, minus 4x, minus 4. Can someone check that?
Yeah.
Okay, here's where we really address the SAT style question. What does the d of negative 2 mean? What is it asking me to do with the negative 2? Plug it in, exactly. So what I'm going to have is a negative 2 cubed plus 2 times negative 2 squared minus 4 times negative 2 minus 4.
And then would you use a calculator for that?
You could, but we can do this in our heads. And folks, if you do use a calculator on this, if you forget your parentheses, you get the problem wrong. All right, let me write this further up just so people in the back can see. Let's do this in our heads, just because it's a good reminder how to cube and square things. So negative 2 cubed is negative 2 times negative 2 times negative 2.
So 8 negative, no wait, positive 8, no negative 8, negative 8.
Because it goes negative times negative
Yeah.
times another negative. All right, now what is negative 2 squared? 4. Then 4 times 2 is good. All right, what's a negative 4 times a negative 2? Positive 8. And then minus 4. Hey, Ellen. Give me like 1 minute. All right, so negative 8 plus 8 cancels out. And then we're left with 8 minus 4, which is 4. So our final answer for this whole problem is 4.
If I know how to do this, if I would have kind of first going to PKCT, because I got like 4 questions of this.
There's tons of this on the SAT. There's tons of this, and you've never really been taught yet. There's one other method. You could actually take minus 2 and plug it in here. Take minus 2 and plug it in here, and then subtract the numbers you got. That would be the same answer. All right. All right, I'm gonna give you guys a packet, and for this packet, where's the packet? Hello. Let me stop recording. So, Alan, you can come in now.